4.1 first introduces us to angles on our Cartesian grid and unit circle. Here is an example of a 45-degree angle. An angle is composed of an initial arm and a terminal arm. The initial arm is an arm of the angle that meets the terminal arm at the origin. The terminal arm is the arm that rotates around the origin counterclockwise or clockwise. This angle is in standard position. To be in standard position, the initial arm of the angle is on the positive side of the x-axis. This angle can also be referred to as a reference angle, which is the smallest angle between the terminal arm and the x-axis. This would be the reference angle of 315 degrees. A unit circle, like the Cartesian grid, is used to make angles. It starts at 0 degrees on the x-axis, 90 degrees at the top, down to 180 degrees, and the bottom of the circle is 270 degrees. Finally, 360 degrees is the same position as 0 degrees. Next, 4.1 talks about special triangles. There are two special triangles that need to be memorized. The first triangle has side lengths of 1, root 3, and a hypotenuse length of 2. This is a scalene triangle, so it has different angle measurements of 30 degrees, 60 degrees, and 90 degrees. An easy way to remember where the measurements go is to remember that the shortest length is opposite to the shortest angle. The second triangle has side lengths of 1, 1, and a hypotenuse length of root 2. It's an isosceles triangle, so two of the angles are the same, the 45 degrees. The last angle is 90 degrees. Special triangles can be used to find exact trig ratios, and in some cases, an unknown side length. This question is asking you to find the 3 exact trig ratios of this triangle. Notice that it matches one of the special triangles. Once you know what special triangle you're dealing with, you can fill out the rest of the angles and side length values, then use SOHCAHTOA to find the ratios. Sine is equal to opposite over hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. The second question is also asking for the exact trig ratios, except this time you're given an angle of 120 degrees. 120 degrees does not match any of the special triangles, but its reference angle, 60 degrees, does. Again, you would fill in the values for the triangle, then use SOHCAHTOA to find the 3 trig ratios. The last question asks, a ladder is leaning against a 10-meter building at a 45-degree angle. How long is the ladder? Since we are given 45 degrees, we know it's one of our special triangles. However, the side lengths are different from usual. You'll need to determine what the relationship between the lengths of both triangles is. In this case, the relationship is 10. Keeping this in mind, the lengths of the original triangle had to be multiplied by 10. So root 2 would have to be multiplied by 10 to get root 2 times 10. Therefore, the length of the ladder is root 2 times 10, which is approximately 14.14. 4.2 starts off with coterminal angles. Coterminal angles are angles that have the same terminal arm. If you think about it, to find coterminal angles, you're just finding different ways to get to the position of the terminal angle. One way of doing this is by starting at standard position and traveling a full 360 degrees, and then travel how many degrees you need to get to standard position. In this example, we have 110 degrees. To find its coterminal angle, you would start at standard position and travel 360 degrees. Then another 110 degrees to get to the terminal arm. In total, you would have traveled 360 degrees plus 110 degrees, giving you a total of 470 degrees. This is your coterminal angle. You can continue this method by just adding 360 each time you loop. You can also find a coterminal angle by traveling in the opposite direction. To get 110 degrees, the terminal arm traveled counterclockwise. The coterminal angle will be however many degrees needed to get to the terminal arm when traveling counterclockwise. This can be found by taking 360 and subtracting 110 from it. Out of all the coterminal angles found, the smallest positive angle you have is called your principal angle. Next is the Castrol. A Cartesian grid is divided into 4 sections called quadrants, and it is also divided into 4 sections according to the Castrol. Cas stands for cos, all, sine, and tan, and starts with the fourth quadrant and ends at the third. It indicates which section the trig ratio will be positive. At C, only the cosine ratio will be positive. In A, all ratios will be positive. In S, only sine will be positive. And in T, only tan will be positive. Here are two questions that use cast. The first question is asking you to find the exact trig ratios of a 300-degree angle. To draw a triangle, have a line connecting your terminal arm to the x-axis. In this question, we would have to use the reference angle to solve for the trig ratios. The reference angle is 60 degrees, one of the special triangles. Use SOHCAHTOA to find the ratios. The last question wants you to find the trig ratios and the last two angles, given that one ratio is cos equals 3/5. Since cos is positive, you know that the angle will be in the fourth quadrant and the first quadrant. Cosine is equal to adjacent over hypotenuse, so your adjacent side has a length of 3 and your hypotenuse has a length of 5. To find your last side, you can use Pythagorean theorem. Now you can use SOHCAHTOA to find the ratios. To find one angle, you'd have to take the inverse of one of the ratios. To be safe, you should use the ratio given in the question. So the inverse of cos 3/5 is 51 degrees approximately. To find your second angle, you're looking for the distance between standard position and the second terminal arm, which can be calculated by subtracting 51 degrees from 360 degrees. This equals approximately 309 degrees.